Peering into the concrete jungle, we uncover how vertical gardens are quietly reshaping the way cities grow food. These stacked ecosystems promise fresh produce where land is scarce, turning walls and rooftops into living farms. Yet behind the green appeal lies a mix of clever engineering and obstacles, from managing artificial light to keeping insects in check. As cities expand upward, farming may have no choice but to follow. At its core, a vertical garden is a method of growing plants on a vertically suspended panel, using techniques like hydroponics, aquaponics, or aeroponics. Instead of sprawling across vast fields, crops are stacked in layers, often within controlled indoor environments. Hydroponics involves growing plants in a nutrient-rich water solution, completely eliminating the need for soil. Aquaponics creates a symbiotic ecosystem where fish and plants thrive together. The fish waste provides natural fertilizer for the plants, and the plants, in turn, filter the water for the fish. Aeroponics, perhaps the most futuristic of the three, involves misting plant roots with nutrient-laden water. These soilless systems allow for precise control over every aspect of plant growth, from water intake and nutrient levels to light exposure and temperature, creating an optimized environment for cultivation that is independent of external weather conditions. This level of control means that crops can be grown year-round, delivering a consistent and predictable harvest that traditional agriculture, with its reliance on seasonal cycles and favorable weather, simply cannot guarantee. These vertical farms can be housed in repurposed shipping containers, abandoned warehouses, or specially designed skyscrapers, transforming underutilized urban spaces into productive agricultural hubs. The push towards vertical farming is born out of a stark reality. Our cities are running out of space. As the global population continues to gravitate towards urban centers, metropolitan areas are expanding at an unprecedented rate. This relentless urban sprawl consumes vast tracts of arable land that were once used for traditional farming. The concrete and asphalt of our ever-growing cities are steadily replacing the fertile soil needed to feed their inhabitants. This expansion not only reduces the amount of land available for agriculture, but also pushes existing farms further and further away from the city centers, where the majority of consumers live. Consequently, the journey from farm to table has become a long and complex logistical chain, often spanning hundreds, if not thousands, of miles. This distance contributes to food spoilage, increases transportation costs, and generates a significant carbon footprint due to the fuel consumed by trucks, ships, and planes. The paradox of modern urban living is that while cities are centers of consumption, they are increasingly disconnected from the sources of their own sustenance, creating a fragile and unsustainable food system that is vulnerable to disruptions in transportation and supply chains. Vertical farming emerges as a powerful solution to this mounting pressure, offering a way to feed growing urban populations by bringing food production directly into the heart of the city. By cultivating crops in vertically stacked layers, these innovative farms can produce significantly more food per square foot than traditional agriculture. This high-density farming model allows a small urban footprint, such as a single warehouse or a small plot of land, to yield a harvest equivalent to that of a much larger conventional farm. This means fresh, locally grown produce can be made available to millions of city dwellers without the need for extensive transportation. The proximity of these farms to consumers drastically reduces food miles, the distance food travels from where it is grown to where it is consumed. This not in turn only cuts down on transportation costs and carbon emissions, but also ensures the produce is delivered at peak freshness and nutritional value. For residents in densely populated areas, this translates to having access to healthy, high-quality fruits and vegetables that were harvested just hours, rather than days or weeks, before reaching their plates. This localization of the food supply chain enhances food security, making cities more self-sufficient and resilient in the face of potential disruptions. A key advantage of vertical farming lies in its remarkably efficient use of resources, particularly water. Many vertical farms operate on closed-loop irrigation systems that recycle and reuse water, resulting in up to 95% less water consumption compared to traditional field farming. In a hydroponic or aeroponic setup, water infused with nutrients is delivered directly to the plant roots in a controlled manner, minimizing waste through evaporation and runoff. The water that is not absorbed by the plants is collected, filtered, and recirculated back into the system. This level of water conservation is a game changer, especially in arid regions or in cities facing water scarcity. However, the energy side of the equation presents a more complex picture. Since these indoor farms lack natural sunlight, they rely heavily on artificial lighting, typically high-intensity LED grow lights, to simulate the solar spectrum necessary for photosynthesis. These lights, along with the climate control systems needed to maintain optimal temperature and humidity, consume a substantial amount of electricity. This energy demand is a significant operational cost and a point of environmental concern. To mitigate this, many vertical farms are increasingly integrating renewable energy sources, such as solar panels installed on the rooftops of the buildings that house them, to power their operations and reduce their carbon footprint. The benefits of vertical gardens for sustainability and the environment extend far beyond resource efficiency. By bringing agriculture into urban environments, vertical farming can help restore ecosystems and reduce the ecological footprint of our food system. Traditional agriculture is a major driver of deforestation, cell degradation, and biodiversity loss. By producing more food on less land, vertical farming can alleviate the pressure to convert natural habitats into farmland. Furthermore, because crops are grown in a controlled, enclosed environment, the need for chemical pesticides, herbicides, and fungicides is virtually eliminated. This not only results in cleaner, healthier produce for consumers, but also prevents the runoff of harmful agricultural chemicals into rivers and groundwater, protecting aquatic ecosystems and preserving water quality. The reduction in food miles also leads to a significant decrease in greenhouse gas emissions from transportation. Moreover, by repurposing derelict buildings and underutilized urban spaces, vertical gardens can contribute to urban renewal, turning blighted areas into vibrant centers of production and fostering a stronger connection between city dwellers and the food they eat. This can lead to a greater appreciation for fresh food and a more conscious approach to consumption. Despite its immense potential, the path to a vertically farmed future is not without its challenges. The primary obstacle is the high initial setup cost. Constructing a technologically advanced vertical farm, complete with sophisticated lighting, climate control, and automated irrigation systems, requires a substantial capital investment. These high startup costs can be a significant barrier to entry for smaller entrepreneurs and can make it difficult for vertical farms to compete on price with produce from large-scale conventional farms, which benefit from economies of scale and subsidized resources. Pest management also presents a unique set of problems. While the enclosed environment helps to keep many common agricultural pests out, if a pest or disease does manage to infiltrate the system, it can spread rapidly throughout the tightly packed crops, potentially leading to catastrophic crop loss. Maintaining a sterile, biosecure environment is crucial and requires rigorous protocols. Ongoing maintenance is another considerable factor. The complex systems that keep a vertical farm running require skilled technicians to operate and maintain, and the continuous monitoring of nutrient levels, pH balances, and lighting schedules adds to the operational complexity and labor costs. Around the world, pioneering cities are already embracing vertical farming, providing real-world examples of its transformative potential. In Singapore, a land-scarce island nation that imports over 90% of its food, companies like Sky Greens have developed tarring, 9-meter-tall frame structures that grow vegetables using minimal land, water, and energy. These low-carbon, hydraulic-powered vertical farms are helping to bolster the country's food security. In the United States, cities like Newark, New Jersey, are home to massive indoor vertical farms. Air Farms, one of the largest in the world, operates from a former steel mill, producing millions of pounds of leafy greens annually using its proprietary aeroponic technology. This facility not only supplies fresh produce to local communities, but also creates jobs and revitalizes a post-industrial area. In Japan, following the Fukushima nuclear disaster, which contaminated large areas of farmland, vertical farming gained significant traction as a safe and reliable method of food production. Companies like Spread have opened large-scale, automated vertical farms that are often referred to as vegetable factories, capable of producing tens of thousands of heads of lettuce per day with minimal human intervention, ensuring a stable supply of clean, safe food. These examples showcase how vertical farming can be adapted to different urban contexts and challenges, from land scarcity to food safety concerns. Looking ahead, the future potential of vertical gardens in urban planning is vast and exciting. As the technology matures and costs decrease, vertical farms could become an integral part of city infrastructure, as common as parks or public transit. Imagine skyscrapers with entire floors dedicated to food production, supplying fresh produce to the residents and offices within the same building. Architects and urban planners are already envisioning agritecture, a new design paradigm that seamlessly integrates food production into the fabric of urban life. Rooftops, building facades, and even underground spaces could be transformed into productive green spaces. This integration could lead to the development of edible cities, where food is grown hyperlocally, fostering community engagement and providing educational opportunities about food systems. The data-driven nature of vertical farming also opens up possibilities for optimization and innovation, using artificial intelligence to fine-tune growing conditions for specific crops, enhancing their flavor, nutritional content, and yield. As cities strive to become smarter, more sustainable, and more resilient, incorporating vertical farming into their long-term planning will be crucial. These living structures are not just a novel way to grow food. They represent a fundamental shift in our relationship with agriculture and a vital step towards creating self-sufficient urban centers of the future.